cathode ray oscilloscope. So the cathode ray oscilloscope consists of the following components. First, we have the electron gun, and then we have deflecting plates, and we have a fluorescence screen. So that is the three main components in cathode ray oscilloscope. Okay, so this is electron gun. Okay, so from here, from the heating filaments to this accelerating anodes, this is the electron gun. This electron gun, and the functions of the electron gun is to produce this cathode ray, a beam of cathode ray. The red one is called, this one is the cathode ray. This electron beam is the cathode ray. So the functions of the electron gun is to produce a cathode ray. The second component is this one. This one is the deflecting system. We have two pairs of plates, Y plate and X plate. Y plates move the cathode ray up, down, and the X plate move the cathode ray left, right. Okay, so that's the deflecting system. And then the third one is the fluorescence screen. The fluorescence screen is to absorb, the small amounts of light energy release when the electrons hit on this screen. Okay, it absorbs a small amount of light and then produce large amounts of light to produce the bright spot. So that is the structures of this cathode ray oscilloscope. So let's start with the filament. Okay, so from here, you close this one first. Okay, from here you can see that there's a filament, heating filaments. Usually is made out of tungstens. Okay, so the functions of the heating filaments is to heat the cathodes. This is the cathode. This is the cathodes. So we use these heating filaments to heat the cathodes. So that is the heating filaments. The cathodes, okay, after heated by the heating filaments up to certain temperature, it will release electrons. Okay, it will release electrons, and so the functions of the cathode is to release electrons when heated by filament. So that is the cathode. Now in front of these cathodes, you can see this this ring here. Okay, this is called the grid. This is called the grid. Now the grid is connected to a negative potential. Negative potential means that it can repel electrons because the cathode release electron. Okay, so this can repel electrons. So we use this to control the amount of electrons that can pass through it. Okay, we control the amount of electrons. And when we control the amount of electrons means we control the brightness. Okay, more electrons pass through it, then it will produce brighter spot. If less electrons pass through it, then it will produce a dimmer spot. So the control grid, this control grid, it controls the amount of electrons to pass through it and therefore control the brightness of the screen, the brightness of the spot on the screen. So the number of electrons reaching the screen determines the brightness of the light. So hence the negative potentials of the grid can be used as a brightness control. This control grid is to control the brightness. Okay, next one is the focusing anode and the accelerating anodes. Okay, from here we can see that there are two anodes. Okay, the first one is called the focusing anode and the second one is called the accelerating anodes. The focusing anodes is to focus the cathode ray. Okay, is to focus the cathode ray. When the electrons release, the electrons move this way. It moves this way. So then we need to have this focusing anodes to focus the electrons beam. So when the electrons release, then the focusing anode will try to focus it. So then it will focus it on the screen. So without these focusing anodes, then the electrons will spread to a wider area. So we must have this focusing anodes to focus this cathode ray. So that it focuses at this fluorescent screen, then we have focused bright spots on the screen. And as we have these accelerating anodes, from the name we know that this is to accelerate the electrons. So when the electron released from here, the speed of the electron is very low. So we need to have an anodes to accelerate the electron so that it moves very fast like this light ray. Okay, light ray move in a straight line. So that is the components in the electron gun. Components in electron guns. Then so after that we have these deflecting systems. We have Y plate and X plate. Now Y plate is used to move the electron beam up or down. So if this is positive, this is negative, then this electron beam will be deflected upwards because this electron beam carry negative charge. Okay, so the negative charge, it will move to the positive plate. So if you want it to move down, then we apply the positive to the lower plate and then the negative to the upper plate, and then it will deflect downwards. So the Y plate deflects the beam up or down, and the X plate deflects the beams left or right. Okay, it deflects the beam left or right. That is the deflecting system. And then here you can see that it's labeled here vacuum. Actually, the whole tube is vacuum. Okay, the whole tube is vacuum. The reasons we need to have vacuum is so that the electrons won't collide with any air particles inside. Okay, so we don't want the electrons to collide with the air particles. If the electrons collide with the air particles, then the electrons will be deflected. Maybe it will go up or go down. So, okay. Then you cannot get one bright spot. So we must use vacuum to prevent the electrons collide with the air particles. So when the electron reach this fluorescent screen, it collide with the fluorescent screen, and after it collide with the fluorescent screen, the kinetic energy change to light energy. The light energy absorbed by this fluorescent substance and then produce this bright spot. On this screen, okay, this is not labeled here. Okay, on this screen, there is also graphite. There are graphite on the screen. Sometimes they may ask you what's the functions of the graphite because the graphite is not given here. Okay, so there are graphite on the screen as well, and then this graphite is channels to the earth. Okay, it's channels to the earth. Because when the electrons hit here, okay, we don't want the electrons to accumulate here. When the electrons accumulate here, then it will create a very high negative voltage. So we don't want this. So when the electrons collide with this fluorescent screen, then the graphite is a conductor. So the graphite will conduct the electrics, okay, to let the electrons to go to the earth wire. This is to remove the electrons from the screen. Okay, to remove electron from the screen, because we don't want to have a negative charged screen here, because if the screen is negatively charged, then it will repel electrons. We don't want that. So we have graphites on the screen, and this is to conduct the electricity so that the electrons can go to the earth. So that is the function of each components. Functions of each components of this cathode ray oscilloscope. So Y plates, the function is to deflect the beams left to right, and then fluorescent screen, okay, is to absorb the lights to produce a bright spot. Okay,